Welcome back to math class. This is Mrs. Witt, and this is lesson 3.1. So week 3, lesson 1, we're going to be discussing additive inverse. So let's start by recalling last week we saw that 7 minus 6 equals 1, and 7 plus a negative 6 equals 1. So on a number line, let's see, last week we worked on that. If we started at 7, and we went 6 in a negative direction, we minused 6, go 1, 2, 3, 4, 5, 6, and we would end up at 1. So that verifies that. And then let's look at it again for this equation right here. So say we started at 7 again, and we're going to add to that a negative 6. So we're going to add to that 6 in the negative direction, left. 1, 2, 3, 4, 5, 6. We ended up at the same place. So if you notice, those two things mean the same thing. Well, we used a number line last week. This week we're going to start adding and subtracting integers using color counters. So it's the same operations we're doing, but we're going to use color counters. That might help some people see things in a different way. It might be something you like, it might not be, but let's explore that. But first we want to make sure we're all talking the same language. So let's go over our key terms. Something we're going to be addressing this week is additive inverse. And all three of these terms are really closely connected. Additive inverse is the number, when you add it to the number you've got, you'll get 0. So it will result in a 0. And what kind of number is that? Well, it's the opposite number. It's the opposite number. So opposite numbers, they have the same value but not the same sign. So remember when we were talking about absolute value? So like negative 2, the absolute value of negative 2, it's the distance from 0 on a number line. So it's always positive, so it's 2. Well, the absolute value of 2 is also 2 because on a number line, if we're looking at it, just to review, 0, 1, 2, negative 1, negative 2. So if we're looking at the absolute value, we're looking for the distance from 0 to negative 2. That was 2 units. But the distance from 0 to positive 2, that was also 2 units. So absolute value was always positive because it was the number. It was the number of spaces from 0 on the number line. So an opposite, so like 2 and negative 2, they're the opposites. They're the same distance from 0, but they don't have the same sign. 2 and negative 2 are different numbers. They might have the same absolute value, but they don't have the same sign. So now when we start talking about here in a few minutes 0 pairs, they're the integer and its opposite. Like in the example above, 2 and negative 2 are opposites. Those are opposites. They both are the same distance from 0, so when you add them together, they make 0. They're a 0 pair. So let's dig into this a little bit. So let's start by thinking of additive inverse, which we already said just a minute ago. Additive inverse means you add them together, they add up to where they equal 0. So let's look at it if we just have 3 minus 3. So if we did it on a number line like what we've been doing, 0, 1, 0, 1, 2, 3. Could go on, it's in line. Say we started at 3. We start at 3, and we subtract 3 spaces, 1, 2, 3, we end up at 0. So that makes sense. Those are additive inverse. 3 minus 3 ends up to 0. But what that really means when we look at it is 3 plus a negative 3. So remember, it's going to be the exact same number line. Oops. Let's erase, where's my undo button? There we go. 1, 2, 3. So again, if we start at 3 and we add that opposite negative 3, we're going to go to the left 3 positions. We're going to move in the negative direction. That equals 0. Well, is it any different if we start at negative 3 and go to 0? Let's look. Are these still, Here we've got a positive number and the negative number, and we saw that those were additive inverse because they ended up at 0. Well, it's the same thing. If we start at negative 3 and we go in the positive direction, 3, we get to 0. So no matter how we put those two together, they're always going to add up to 0 on a number line. They are additive inverse. So negative 3 and 3. That's a 0 pair. They add up to 0. They're an additive inverse. Here 3 is the additive inverse of negative 3. Are we kind of getting what this is meaning here? So the big thing is that additive inverse means when you combine them, when you add them together, they are a 0. So now let's look at this using color counters. Color counters or chips, however you want to look at them, we're going to represent those. We're going to use these to represent the integers that we are combining. So yellow chips stand for a positive 1 and red chips stand for a negative 1. So let's look at 3 plus a negative 3 like we just did. Let's say we've got 3 positive integers, 3 positive 1s here. So that's 1, 2, 3. Okay, so that is what 3 is representing. And we want to add to that a negative 3. So minus 1, minus 2, minus 3. And we want to figure out where that goes. Well, in a number line, we saw that we started at the right, and then we went backwards, and we ended up at 0. Well, if we're using our chips here, or our color counters, we know that when we combine plus 1, minus 1, so 1 minus 1, the result is 0, right? So if I kind of group these together, they equal 0. And I group these together, those equal 0. And I group these together, those equal 0. So all of those combined together just equals 0. Now you might have heard words like cancel, they cancel each other out, or they eliminate each other. Both of those words are words that you might hear. Those are just kind of shortcut words, but what it's really telling us is that they add to 0. So it looks like it makes them disappear. It looks like they cancel each other out. But if we use that terminology, I want you to remember what cancel really means when we're adding and subtracting. It means that together those make 0. Okay? So now let's look at an example where they're not. So here we saw that those made 0 pairs. They were additive inverse. And this, you know what, I don't like that necessarily a lot, thinking about additive inverse, but let's just think about using the color counters. Okay, we're using color counters. So we want to know, what would it be like if they weren't evenly matched like that? What if they weren't just the additive inverse of those? That's what we were looking at. So now let's look at if we have a negative 3 plus 4. Well, let's start by grouping together our 0 pairs. Well, this is a 0 pair because a plus 1 and a minus 1 equals 0. This is a 0 pair, and this is a 0 pair. So if we know that these end up as 0, these all end up as 0. Like I said, if you've heard it say canceled, what that really means is they add up to 0, so we don't have to think about them anymore. The only thing left over is this positive 1. So we can say that negative 3 plus 4 equals 1. So after we stop paying attention to our 0 pairs, they've added to 0, they balance kind of, we still have that one positive chip left over. Okay, well, what if there's more negatives? Okay, so let's look at this one again. This is a 0 pair, this is a 0 pair, this is a 0 pair. So we don't have to look at those anymore because those all added up to 0. What's the only thing left? A negative 1. So we know that 3 plus a negative 4 is negative 1. And remember, 3 plus a negative 4, you might also see it looking like 3 minus 4. This represents, either way you look at that, it's that same situation. Those both equal negative 1. Okay, what about if they're the same? They're all negatives. There's no zero pairs there. Okay, well then if there's nothing that we can add up to zero, let's just combine, see how many we have. See, this gives us -1, 2, 3, 4, 5, 6, 7. -7. They're all negatives, so we count them all together. There's nothing that will add up to zero to get rid of them right now. So we know that -3 plus a -4 equals 7. Or I'm sorry, -7. So let's kind of think about this, wrap it all together. What is the connection between absolute value and opposite numbers? Well, some of the things we might say is that the absolute value, what do we know about absolute value? Absolute value is the distance from zero Well, what do we know about opposite numbers? Well, opposite numbers, those are the same distance from zero, but they're not the same sign. Okay, what is the connection between additive inverse and a zero pair? Well, we know that additive inverse, and again, remember, you write down what helps you remember these things. I do a lot of abbreviating, and I use arrows and whatnot. But additive inverse, we know that if we add those numbers together, they're going to equal 0. And that's pretty much what a zero pair is too, right? So when we talk about a zero pair and we're talking about an additive inverse, we're basically representing the same situation. Okay, so let's look ahead at what's going on. I feel like we worked through some questions last week in class, but I want to make sure that we're all on the same track for this. So today is Monday, Tuesday. So after today's lesson, after you watch this lesson, you're going to complete the remaining tasks on Canvas that are listed underneath your Monday, Tuesday entry, okay? So you're going to watch the short video on additive inverse introduction. It's on the module. There's a link to it, and it will just kind of reinforce what we talked about. And then I want you to play at least one round of the additive inverse game that there's a link on the module. Okay, again, that's just practice. That's helping you kind of spot what matches up. Then you'll watch the short video, and each of these videos are literally a couple minutes. Watch a short video on color counters introduction in the module. It's basically going to go over the same thing that I said, but maybe if you have any questions, that'll help you sort through it. And then you're going to complete the color counters practice on the module and record your answers in the text box provided when you hit the submit button. So all you have to submit to me is just the answers to those questions, just the answers. Now, that is not part of your choice board. That is not part of your grade. That is a formative measure for me to look at and see if you're getting it. So I got a lot of questions about the practice last week. The practice is for me to check your understanding and for you to check your own understanding. Once you're finished with that, you can complete the digital exit ticket, which is also on the module on Canvas. And that's just got a series of questions for me to kind of make sure that you're understanding what I'm trying to get you to see, or to leave any questions for me you might have. Any extra time, so this is not going to take 98 minutes, all right? All of the things that I've given you to do for Monday or Tuesday is not going to take 90 minutes. The rest of your 98 minutes of math time, you should be working on choice board activities, okay? You have the opportunity to correct if you didn't get your full 20 points last week because maybe you turned in math that was incorrect or didn't turn something in. I'm giving you an opportunity to fix that now. You can go back and look at the feedback I gave you on your grades, on your submission, and correct that. Or if you've already done that, because some of you have done an amazing job at doing that, you can go ahead and start working on Choice Board 3. And remember that Choice Boards cover the entire week, and they're due on Friday. So this week, it's not that much of a big deal. I'm not going to introduce any new material on the rest of the week. We're just going to be practicing what we know. But last week, I feel like some of you jumped ahead. You did great. You did work on it, but then you had to rework some of your problems that dealt with GEMS, with our order of operations. So just remember that they go for the whole week, and they're due on Friday. Now, I will accept late submissions, but I grade them on like Friday night, and I try to get those grades in the grade book on my weekend. So with that in mind, you can turn in something later. However, it may not go in the grade book right away, because that time I expect you to get your work to me on Friday, and I'll have that work back, your feedback back to you over the weekend. But if you turn something in on like Saturday night or Sunday night, I'll still accept it, but you may not get an immediate reflection in your grades. You know, that you might have to wait a little bit, because the same way you guys want a little bit of time to do things on your own, I do too. So I'm going to allow a certain amount of time for grading on the weekend, but I will maybe some of it might end up being put off until Monday. Okay? Remember, you are in control of your learning. So, my dear friend Yoda there, practice self-discipline you shall. You guys are doing a great job. Go on and work on the rest of your Canvas module now.